Okay, good evening, students. Those who are in the online, can you hear me? Okay, right. We just start this logic gate Boolean algebra lesson. Now, this is one of the important lesson because entire computer operation, remember, will be based on this logic gates or Boolean algebra. And exam paper also you will get several questions. Therefore, you need to learn this one properly. Uh, because the entire computer operation in the machine will depends on this, what we call the logic gates for Boolean algebra. Now, this was initially introduced by George Boole in 1854. Actually, he introduced this one. I remember when he introduced this in the 1854, uh, no one could understand this because it is a separate mathematics which is only working with two values. That is, we call as a true false or 1 and 0. So therefore, once this one developed by the George Boole in 1854, no one has accepted. Everyone reject because there were no practical application to show his theory. But after about 100 years, when the first generation computers are developed, like digital systems are developed, then the people realize whatever thing he proposed in 100 years back is purely correct. That is why, as honor, this mathematics section called as a Boolean algebra by taking part of his name. That is how this was initiated in 1854. But at the time he introduced, no one accept theory because there were no practical application to prove it. Then, like when you have learned this mathematics, you have to learn the operators. Now, when you're in the grade 6, 7 or 5, 6, you have learned about the operators like addition, subtraction, multiplication, like you have learned the operators. Similarly, here we have different operators. Now, today we just look at only these very basic operators and or not. And again, and the no, universal operators. So these are the operators in this today lesson we have just discussed uh, according to this syllabus. Now, then to understand about each operator, we will take this example. Now, to understand the AND operator, we are taking this example or the circuit. Here you can see the circuit, the bulb will be on. What are the conditions that must be satisfied? Here this bulb will be on when this switches, switch A and the switch B, both should be on. Is that clear? When the both are on, light will be on. So therefore, you can see the bulb will be on. What will be on? What is the condition? Switch A and. You can see the word and is coming here. Switch A and switch B, both should be on. Is that clear? Then only light will be on. So then this can be considered as AND operator. So then you can see here, when the both switches A and B are off, the light will not be on. When the one of the switch is off, still light will be off. Then the light will be on when the both conditions are satisfied. That means when the both A and B are on, light will be on. So that is the relationship you can build here for this for this AND gate actually. This will represent the input-output relationships. Now this relationship can be further described using the concept of this Boolean algebra, where you can consider on means true, off means false. Now, when you take the on is true, off is false, you can map this table into this one. Then this will represent the input-output relationship using true and false. Therefore, this table, which has only true and false relationships for the given inputs and outputs, so this table we call as truth table. This table we call as a truth table where we represent true-false relationship between the inputs and outputs. However, this can be further simplified by taking the false is 0, like here. and the true is 1, like this. So once you take the false is 0, true is 1, your table would be like this. So in general, when you ask to draw the truth table in the exams, actually we don't draw the truth table like this one. We don't draw this one, but we draw this one when you ask for the truth table, where you have the 0 and 1, not true, false. Is it clear? So then, according to this truth table, you will see that there's a pattern for this output. This output you can get. This output you can get by multiplying A and B. Because when you multiply 0 and 0, answer will be 0. When you multiply 0 and 1, answer will be 0. When you multiply 1 and 0, answer will be 0. When you multiply 1 and 1, answer will be 1. So therefore, you can consider this AND operator similar to in mathematics, which one? Multiplication. Is it clear? So then the summary you should know here, the AND operator should be equal to multiplication. So then we have the symbol to represent the AND operation. Now, this is a standard symbol we are using for the AND operator is this one. When you input A and B, what happened to the output? For the output, these two will be multiplied together. Output results you get by multiplying together. So in the truth table, also no need to memorize. You have to just remember for the truth table, for the AND gate, you have to just multiply. By multiplying, you can get this output column. So then, without memorizing, only thing you have to just know that AND operator means basically multiplication. Then we just go to the next operator, which is what we call the operator. So in the operator, remember, you can use the other circuit given here. Now this content I have already shared in the WhatsApp group. You can get that one. Now, for this one, we can take the circuit operator, this circuit here. We have the switch in similar or parallel switch we have. So then you can see here, the condition is, we can say the light will be on. The bulb will be on. What's the condition? Either switch A or switch B. You can see the operation. Either this one is on or this one is on or both are on. If the one of them is on, light will be on. Because when the one of them is on, circuit get connected, then the light will be on. So therefore, this represents the operation. Therefore, input-output relationships, when any of the switch is on, if the one A is on or if the B is on, if the both are on, the light will be on. Then you can see, you get the truth table relationships like this. So then we can map that into true, false, and 1, 0. Then final truth table will be like this. So then you can see the mathematical relationship for the operation. You can get the operation output column by adding the inputs. If you add 0 plus 0, answer will be 0. If you add 0 plus 1, answer will be 1. If you add 1 plus 0, answer will be 1. If you add 1 plus 1, answer will be 2. But in the Boolean algebra, only two values, just 0 and 1. Therefore, the output is 1. So then you have to remember, operation is similar to which one? Operation is same as addition. So that is what you should keep in mind. Operation is same as addition. Now this is the symbol or notation for the operations. Once you input the A and B, what it does, OR gate will do the addition. We'll get the addition. Then how to get the output? Just remember, operation output is addition of the inputs. By adding the inputs, you will get this out. So that is the other operator that you should know. Okay. Then the third basic gate is actually NOT operator. This NOT operator, or we call as inversion. The notation is this. As you know, when you take this logically, not true. Not true means actually false. Is that clear? When you take the not, if it is true, not true means false. If it is false, not false means true. Is it clear? In logically, not true means what? False. Not false means what? True. So therefore, this will perform the inversion. That is 0 will be 1, 1 will be 0. Now this is the notation we have to use for this not operator. Whatever you input, this will add the bar O dash output. Is it clear? So those are the three basic operators that you should know: AND, O, and NOT. As a summary, AND means multiplication, O means addition, NOT means inversion. Is it clear? Okay, this one, is it possible to find the Boolean expressions for the output? So I just give you few minutes. Can you get the expressions for the output? No need to draw this one. Just write the output. So if you take the first one, you have to identify the gate. Now the first one, this one is O gate. O gate does the addition. This one is AND gate. AND gate does the multiplication. This one is AND gate. AND gate does the multiplication. That is how you have to identify the gate and then get the expression. Now in here, the output is addition of A and B. So A plus B. This one is multiplication. What are the inputs? B and C. It will multiply. So therefore, what is the output here? A plus B multiply BC. Remember, when you have the multiplication, the bracket is compulsory. If you don't put the bracket, your answer is wrong. If you don't put the bracket, answer is wrong. So that will be the output you get in the first one. Bracket is compulsory. Okay. Then the second one here, this one is actually not B. So this is also addition. So it will add A plus B bar. So it will add A plus B bar because not B is there. Therefore, here the value is A plus B bar. And then here this is the AND gate. AND gate, what it does, it multiply. So therefore, it multiply the inputs. So the input is, one input is A plus B bar multiply by C. For multiplication, if you want, you can put the dots, but it is not compulsory to have the dot. So therefore, here this is A plus B bar and multiplied by C. That is the output you get. And for the other one, this one is actually multiplication AND gate A B bar. And this one multiplication A bar B. So the first one will do the multiplication of A and B bar. And the second one is A bar B. And then this one is OR gate. This one is OR gate. We know that OR gate is addition. Therefore, it will add those two expressions. So the output is AB, but first one is AB bar. First one is AB bar. Second one is A bar B. That's the expression you get. Then for the other one, first of all, it does the addition A plus B. And here this will add the not. A plus B. Remember, it's a not operation. So not operation, what it does, it will add the bar. Like this. And the next one will multiply B and C bar. Will be multiplied together. Then those two again multiply in the final output. That is A plus B bar multiply BC bar. So the output is A plus B bar and BC bar. Is that clear? Next two, can you write? Okay, next one. This is AND gate. We just multiply A and B. This is OR gate, which will do the addition B plus C. This again AND gate, which will multiply B and C. And this will multiply those two together. Bracket is compulsory. If you don't put the bracket, answer will be wrong. BC. And that should be added here. This is OR gate. So AB plus B plus C. But if you change the order, that doesn't matter actually. When you write in this order, if I write AB first, AB later, doesn't matter. Order is not important, okay? Is that clear? Order is not important. That means you can write, the answer here is actually write the BC multiply B plus C plus AB. That is also correct. No difference. Order is not important in the terms in the expression. Is it clear? You can write any order. So that is the output you will get. And then next one, this again AND gate. So it multiply P, Q bar. And here multiplication P bar Q bar actually. So this one is PQ bar and this one is P bar and Q bar. And this OR gate does the addition. That is PQ plus PQ bar. So in that case, PQ bar P bar and Q bar. Is that clear? Did you get that answer? Harideka. So actually it is not difficult once you understood the concept. It is very easy. Then if you go to the next page, now next page again we have very important thing, which is what we call the operator precedence. Now in mathematics, we have learned operator precedence, which is what we call the BODMAS. That is bracket of division, multiplication, addition, subtraction. So where are we going to use that? Now when you have the expressions with multiple operators like this one, in here, which one we do first? Is it the addition? Is it the multiplication? We do the multiplication first. Why? Multiplication is higher than the addition. Multiplication is higher, addition is lower. Therefore, we do the multiplication first. But in the second one, which one you do first? That is, do the addition first. Why do the addition first? Because you have to complete the bracket first. You have to complete the bracket. So therefore, we do the addition there because of the brackets is getting the high priority. So like, we have to use that way to get the correct answer. Now, if you do the addition here, you get a wrong answer here. Is that clear? In this case, if you add these two first and multiply by 10, wrong answer is coming. Similarly, in Boolean algebra also we have the operator precedence. What is the operator precedence? Again, the bracket is in the top level, highest one. And then next one is what? Not. And next one is and. Finally what? O. So those are the way you have to know the operator precedence. Is it clear? So then just remember, operator precedence here is actually bracket, not, and O. So if you take this expression, first you have to complete the multiplication and then the addition actually. If there is a not, we have to complete the not first and then do the multiplication and then do the addition. So just remember, this is again very important when you're going to the truth table or when you're going to the logic gate diagram. This is very important. Okay, this one, can you write the answers? I think it's very easy. So now you know the notations. Based on that, you can draw it. So AND gate is multiplication. Once you input the values, you just do the multiplication. And the OR gate and the NOT gate. So like you should be able to draw the logic gate notations. Then you have to find the truth table. So that is again bit easy actually because inputs are 0 and 0. and 0 and 1, 1 and 0, 1 and 1. So those are the inputs you get. Now AND operation means multiplication. When you multiply this 0, 0, 0, 1. So that is the AND gate truth table. OR gate, it's addition, 0 and 0, 0 and 1, 1 and 0, like this. Then O is addition, you can add them together. Then the answer will be 0, 1, 1, 1. When you add them together, you get the output like this. And NOT operator, 0 means not 0 is 1. 1 means not 1 is 0. So that's the truth table you get. Is it clear? Okay, then can you go to the next question? Now this one, we have to draw the circuit. So first of all, you have to do the NOT operation, remember. First thing is NOT. Therefore, we have to have the B bar. That should be connected with the A. So addition is done by the OR gate. And output here. Then the one input A is here. B is here. So the output is A plus B bar. Okay. Then how do you draw the truth table here? Now to draw the truth table, you have to create the table. Now which has two inputs A and B. But in the expression, we have B bar. So you have to find what is B bar. And then you can get the output. So we have the input A, input B. And remember, you have to have the B bar, sorry. We have the input A and input B. And you have the B bar. And then addition, A plus B bar. So first you can have the column input AB, which will be 0 and 0, 0 and 1, 1 and 0, 1 and 1. And here we have to find out, because expression we have the B bar. So then we have to have the B bar. Then you can get the A plus B bar. So B, we know that 0 and 1. So B bar will be 1 and 0. Now I have to do the addition between those two columns, A column and the B bar column. So when you add them together, you will get the 1 and 0, 1 and 1. So that should be the output you should get. Did you get that? Okay, now Boolean expressions actually earlier we did. For this one, you have to draw the truth table. So can you draw the truth table for the first two? Now, in the first one, we have three inputs. No, actually, SOPPO is I'm not going to do today, actually. I just start and discuss some questions for the initial part. Next week, probably we can do it. Now, first of all, we know the expression here. The expression is actually here A plus B and multiply with BC. Therefore, expression output is A plus B multiply with BC. That's the expression. So, we need to have three inputs here, A, B, and C. So, when you have three inputs in the table, we will get 8. And when you have three inputs in the table, we may get 8 combinations. So we need to have we want to have the ABC inputs. Now look at the expression. Expression you have to complete the bracket first, A plus B. So you have the column A plus B. And you have to multiply B and C. For that, you have to have another column. And finally, output. So, in the table, we have three inputs, A, B, and C. Those are the inputs. And then next, we want to have the bracket, that is A plus B. Should be completed. And next, you have to find the B and C. Finally, you have to multiply all of them together. A plus B should multiply the BC. Those are the columns that should be there in the table. So the inputs, remember, we will get the 3 inputs. Then you get the 8 combinations. This one also you don't need to memorize actually. The column C, what are the values? Column C values you are getting actually just change in the column C, what are the values? Just change 0, 1, 0, 1 alternately 8 times. Column B, just change 2, 0, 2, 1. Column A, you have to change 4, 0, and 4, 1. That is how you get the columns, the values. Now, in the first one, we have to do the addition. A and B should be added together. So you can add A and B. When you add A and B here, first one is 0. Next one also 0. Next one is 0 plus 1, 1. 1, 1, 1, 1, 1. So those are the additions. Next one is B and C should multiply together. When you multiply B and C, 0 here, 0 here, 0 here, 1. Again, 0 here and 0 here, 0 here, and 1. So that is the multiplied results you will get. Then to get the final columns, we need to multiply these two together. When you multiply these two together, 0, 0, 0, 1. Again, 0, 0, 0, 1. So that will be the output column. Is it clear? Did you get that output or truth table? ඒක හරිද ඔයගොල්ලන්ගේ? Now for the second one, okay, good. Now the second one, we have to first find the expression. So here the expression is actually A plus B bracket and BC bar. Now this gets more column actually, A plus B bar and B C bar. Then we have to draw the columns here. So first you have to have the ABC inputs and A plus B and A plus B bar and C bar, BC bar and the results. So first we need to have the inputs A, B, C. And first column, we have the A plus B. Next one is A plus B bar. Next one is C bar. Next one is BC bar. Next one, final multiplication, A plus B multiplied BC bar. First column A plus B, here A plus B bar, here C bar, here BC bar, here multiply all of them together. Now, when you take the inputs 0, 0, 0. So those are the inputs. First, you add them together, A plus B. When you add them together, you get 0, 0. After that, all are 1. Addition. Then the inversion of that, these two will be 1 and others will be 0. And C bar will be 1 and 0. Then B and C should multiply together. Sorry, B and C bar. Then it will be 0, 0. It is 1. And then 0. This will be the output. Then you have to multiply these two columns together. The output will be 0. Yeah, all are 0 actually output. Did you get that? Is it correct? Okay, good. Did you get the transfer? Is it clear? Okay, good. Then I think others, I'm not going to do that. You can just try out. Uh, I just get this one. Now here the expression is, output expression is AB bar plus A bar B. Expression is here actually A B bar and A bar B. Then the truth table, we have only two inputs. Only two inputs. That is A B. But to get the final output, you have to find out the A bar, B bar, we have to find out, A B bar, we have to find out, and A bar B, you have to find out, and then the final expression. So we have only two inputs, A and B. But you have to find out the A bar, you have to find out the B bar, you have to find out A B bar and A bar B, and addition of those should find. So we have to find out A bar is needed, B bar is needed, and A bar B is needed, A B bar is needed, and addition of those two. That's the final expression. So then inputs, only two inputs. It can be 0 and 0, 0 and 1, 1 and 0, 1 and 1. Those are the possible inputs. Then A bar inversion 1, 1, 0, 0. The next one 1, 0, 1, 0. Then you have to multiply A bar and B. If you multiply the columns A bar and B, you get 0, 1, 0, 0. If you multiply A columns and B bar columns, then you will get 0, 0, 1, 0. Then you can add the both columns together, then the answer will be 0, 1, 1, 0. So that is the output expression you should get. Did you get that? Is it correct? Okay. Then okay, for these expressions, can you write the Boolean expressions actually? The first one I just explained. Now, if you take the first one, how do you write this in the Boolean terms? So first one is not B. First one is not B. Not B means actually, sorry, not A. Not A means A bar. O means addition. B, and means multiplication. So therefore, it is equal to, first one is not A. Not A means A bar. Not A means A bar. O means addition. And means multiplication. B and C. Okay. Then other two, can you write the expression? Boolean expressions. You have to remember N means multiplication, O means addition, not means bar. So this one is A and N means multiplication, not B. Not B means actually B bar. O means addition, not C means C bar. Therefore, A and not B. Not B means B bar. O means addition, not C means C bar. This is how you should get the expression. And for the next one, A, N means multiplication, bracket, not B plus C. O means C. But there's a not operator. Not operator means you have to put the bar. Only for these two. That is how you should find the expression. Okay. I think it's won't be difficult one. You can understand it. Is it clear? Okay, then for the next one, can you draw the uh, logic gate and the truth table? Can you do it quickly? You have to remember the operator precedence also. So this has three inputs. A, B, and C. First, you have to do the addition A plus B and multiply B and C and get the BC bar. So inputs are A, B, and C. First, you have to find the A plus B addition. And you have to find the BC multiplication. And you have to find the BC bar. Then finally, we have to calculate A plus B bracket BC bar. So then the ABC inputs are so those are the inputs. First, you have to do the addition. A plus B, you can add them together. When you add them together, you get 0, 0. After that, everything is 1. And BC, you can multiply together. When you multiply together, B and C, it will be 0, 0, 1, 0. Then again 0, 0, 1, 0. Then you have to get the inversion of that actually. For the next one, we have to get the inversion. Then it will be 1, 1, 1, 0, 1. 1, 1, 1, 0, 1. That's the inversion you get. Now I have to multiply second column and the fourth column together. When you multiply, you get 0, 0, 0. 1, 1, 1, 0, 1. Is that correct? Did you get that output? In the gate, first of all, you have to complete the bracket A and B addition. Addition is done by the OR gate.
Excuse me, sir. The BC, I think the BC column is wrong.
BC column. Yes, 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 correct. Yeah. Yes, correct. BC multiplication. Yes, it should be 0, 0, 0, 1. 0, 0, 0, 1. Yes, that's correct. And then next one is BC bar. It will be 1, 1, 1, 0. 1, 1, 1, 0. Yes. Now I have to multiply these two together. Yes, then you get 0, 0, 1, 0, 1, 1, 1, 0. Is that correct now? Did you get that? Hmm? Is that correct? ආවද උත්තරේ? වැරදිද? Correct.
Yes, sir. Now it's okay.
Okay, right. Thanks. Now the logic gate. Yes, thank you for that correction. Now next one is A plus B must be added. A and B should be added. For that, B and C should multiply together. Multiplication done by the AND gate, and you get the NOT operator. And those two should be multiplied together again. So that should be done by the AND gate, like this. So you should have the inputs like this. Okay. Is that okay? Any doubts? That's clear, ne? Next question, I think. But this expression you get, we did similar kind of question. It should be A bar B plus AB bar. Okay, we did similar kind of one previously. Okay, now we go to this MCQ. Now, first question, what is the answer? If the three inputs OR gate has 8 inputs possibilities, how many of those possibilities will result in high? High means what? High and low. High means 1, low means what? 0. Now you're asking, we have OR gate, we have the 8 inputs. Out of that, how many of them are 1? Huh? We have we have 8 input combinations. Now we have, let's say, A, B, and C. Okay, inputs. And then if you have the truth table like this, now question is asking if the truth table is having this 8 inputs. Out of that, how many of them are what? It's OR gate, ne? So then 0, 0, 0. Then 0, 0, 1. Then 0, 1, 0. Then 0, 1, 1. Then 1, 0, 0. Then 1, 0, 1. Then 1, 1, 0. Then 1, 1, 1. So we have the inputs like this. Now this is a OR gate. OR gate, what it does? OR gate does the addition A plus B plus C. Okay. It does the addition. So if you add them together, what's output you get? All the three inputs, when you add them together, first one 0, 0, 0. It's 0. All the others will be, when you add them, what happened? All the others will be how much? 1. Therefore, how many of them are 1? 7. Is that clear? That's the question is asking. 7 of them are 1. Is it clear? Out of all the inputs possibilities, 7 of them are 1. Then let's go to the next question. So I think it's easy. Which logical operations are for represented by the plus sign? Plus sign is for what? Addition. Addition for what gate? O gate. Okay. That's easy, I think. Next one. What's output? For the first one, the expression here you get multiplication, that is A bar multiplied by B bar. This is just multiply A and B. And this will add them together. That is AB plus AB. So in this case, remember, now can you tell me what should I write here? Now in this one, what should I write? If I write like this, is it correct? Tell me whether it is correct or wrong. It's
It's
wrong.
wrong.
Yeah, it's wrong because it is actually multiplication of what? It is multiplication of A bar separately because here the one input is A bar. Okay. Other input is B bar. You are writing separately, not together. Therefore, final output is here. This one is A bar. Other one is B bar. Remember, they are two separate things, not together. A bar, B bar plus AB. So the answer is D. This one. Is that clear? So these lessons are not difficult actually. Only thing you have to just understand and you have to have the logical reasoning and do it. Very easy questions actually. But that will improve your logical thinking and reasoning, how you can solve the problem with the knowledge, like those skill will be improved once you study this kind of lesson. Is that clear? Any question? Okay, then next question. Now consider the integrated circuits given below. If the 2 and 3 are 0 and 0, what is the value of 0? Now actually here there's a one thing I have to explain. Now when we have a circle here, remember this circle indicates a not operation in a gate. So here the second one is this one. This one is 0, this one is 0 actually. And then it's to the addition. 0 plus 0, how much? 0. But this is not operation. Not 0 means how much? 1. So the output should be 1. Output should be 1. Okay. Now in the next question, you are given the reverse operation. Now you are given the logic truth table is given, asking the the Boolean expression. Can you find it? Now this one, how do you find out the output actually? So one thing you can see here, if you take the inversion of these values, then this will be 0, 0, 0, and 1. So that is the output value you will get. That is 0, 0, 0, 1. So then that output actually you are getting, but by doing the multiplication A and B. Okay. This output gets by just multiplying A and B. When you multiply A and B, you will get this out. Okay. Because when you multiply the inputs A and B, 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1. So this output you get just multiplying AB. That means AND operation. So therefore, this will be inversion of that actually. This will be inversion of that. That means AB bar. That will be AB bar. So that gate is representing, this truth table is representing AB bar, inversion of that. Is that clear? Then the next one also you can see when you take the inversion of this output, this will be 0 and then 1, 1, 1. So that output you are getting by doing what? Addition. When you add them together, you get this output, A plus B. A plus B output you get here. Then you can see the column is inversion of that. Therefore, you can consider this truth table should be A plus B bar, inversion of that. Therefore, this truth table is representing which one? A plus B bar. Is it clear? That's how you need to find out what is the Boolean expressions when the truth table is given. Is that clear? Haridev?
Sir, it's the NAND gate and NOR gate. No, sir.
Yes, yes. And get a note. Since I have not explained, that is why I didn't tell that one. Because the next part here discuss about the NAND and the NOR gates. Yes, that is NAND and the NOR gates actually. Okay, just go to the next part. Now in this one, it's very easy actually. How do you find out the output? Now to find the output, actually, we don't need to find the expression. You can take each inputs. You can take each input. First input is 0 and 0. You can just input them 0 and 0. Then it's a multiplication, answer will be 0. And not operation means 1. And this one is also 0. 0 plus 1 is how much? 1. Therefore, output is how much? 1. Is that clear? Then you can take the next input. So next input is 0 and 1. So next input is 0 and 1. This is 1. Then you can see this is 1 means obviously whatever the other value comes, 1 plus something is 1. Answer will be 1. Is it clear? In the OR gate, if the one input is 1, output should be 1. Next one is 1 and 0. So next one is 1 and 0. When it is 1 and 0, this is 1. This is 0. This is 0. 1 into 0 is 0 multiplication. Not 0 is 1. Then output will be how much? 1. Okay. Next one is 1 and 1. This is 1 means definitely this will be 1. So the answer will be 1. So therefore, answer is which one? Fourth one. Come to me, right in. No. It's right in. So answer is 1, 1, 1, 1. The next one. I think it's very easy, which is what gate? A and B. And because light will be on when the switch A and B, when the both switches are on, AND operation. So AND operation means what is AND gate here? AND gate is this one. Okay. Then can you try the next question? What is the answer for the next one? For that, you have to go to the backward in the circuit. So anyone completed? What is the answer?
A0 and B1.
A is 0, B is 1. Is that correct for the others? Correct? Okay. Now, how do you reach the answer here? Now, we are given in this circuit, output is 1. That is, this is 1. This is 1 means here should be how much? 0. Because if it is 0 or not 0 is 1. Is that clear? This is the O gate. O gate means addition. What number should be added? Answer to be 0. When you have 1 and 0. 0 and 0. Otherwise, we don't get 0 only. Because only we have 0 and 1. No negative numbers you don't get. Therefore, these two should be 0 and 0. This one 0 means this one how much? 1. Okay, this is 1. That means B is 1. The B is 1. Here the output is 0. Then A should be how much? 0. That is A is 0, B is 1. That's very easy. Okay. Next one. What should be the answer? Anyone? What is the answer? A is 1, B is 1. Is that correct? Because this is a AND gate. AND gate is a multiplication. In multiplication, answer will be 1 when the both inputs are 1 and 1. Because 1 into 1, you get the 1. And that is 1 means this also be 1, this should be 1. That means this should be 1 and 1. That means A is 1, B is 1. Is that clear? So the answer is A is 1, B is 1. Very easy. Okay, then we just go to the next part. That is basically what we call the universal gates. Now remember these universal gates are NAND gate and the NOR gates are we call as universal gates actually. Now what's the reason to call them as universal? Remember the reasons to call them as universal gates. these gates manufacturing cost. What is the material that is needed to develop this NAND gate and the NOR gate are very low. So the manufacturing cost is very low. That is one reason. Another reason is they are consuming very less power because these circuits need some energy or that needs some electric power. So this NAND gate and the LOR gates are utilizing very low power actually. And the other thing is all the other gates you can build using these two gates. Therefore, in practically, all the basic gates and other gates are built using those two gates because these two gates cost is very low and the power consumption is very low. That is why we call them as universal gates. That is actually NAND gate and NOR gate. We call as universal gates. So then basically NAND means not AND, not AND. AND means multiplication. The not means you put the bar. Therefore, this is the NAND. Now, remember this NAND gate, you can draw like this. This is the AND gate, and they have NOT gate here. So, you can draw the logic gate like this. Or in practically, most of the books are using, instead of this, actually, you just put a circle here. When you put a circle, that means what operation? Not operation. Is that clear? Then, we use this notation as the NAND gate notation. Then we know that truth table AND gate is multiplication. Then inversion of that is this one. That is why when you get the output like this should be what gate? NAND gate, not AND. Okay? That is not AND. Then the other one is actually OR gate. That is not TOR. OR gate is addition, not TOR. That is A plus B bar. Then again, for this also you can use not TOR. This circuit can be used, but most of the books are using and the exam paper also using this one. That is circle is indicating what operation, not operation. Therefore, operation is addition. Addition to the inverse of that. Inverse of that is which? Then, what are the things you should remember? NAND means not AND. NOR means not TOR. And this NAND gate and the NOR gates we call as universal gates. Why are we calling them as universal gates? Manufacturing cost is low, power consumption is low, and all the other good gates can be built using these two gates. That's the reason. Say those are universal. පැහැදිලිද ඒක? So here we have just a summary. The things that you should know up to this AND gate. You need to remember AND means what is it? Multiplication. Okay, AND means multiplication. Then a logic gate is this one. Then you have the truth table. Truth table, you have to just remember the multiplication. O means which one? Addition. O means addition. So you can just add them together. Not, that is inversion. 0 will be 1, 1 will be 0. NAND and the NOR are universal gates. NAND means not AND. NOR means not TOR. Then NAND means multiplication A and B. NAND means AND means multiplication of A and B. NAND means not A, B bar. And NOR means addition A plus B O, then A plus B bar. That is a NOR. Then you have to remember the truth table also for both gates. Is it clear? Okay, these two, can you first find the truth table? Did you do both? What's the relationship? Now, once you finish, what can you say about both expressions? Can you see that the last columns are equal? The output here, this output column and this output column, what happened? Equal. Can you see that? They are equal. So they are equal means actually these two expressions, this expression and this expressions are equal. That will do same output. Is it clear? Yes. Because here, yeah, two output columns are equal. That means the Boolean expressions are equal. That's the meaning. Okay. Any question? Is that clear? Okay, this one. First question, can you tell me what is the answer? Anyone, can you tell me the answer? You can think that answer if you can draw the truth table. With the truth table, we have to consider only B is how much? 1. Because it says that B is always 1. We cannot take any other values. Then if you draw the truth table, then you can easily understand what should be the answer. So A and B are the inputs. You have to find out what is the output. Now in this case, actually the B, only value B can have is 1. Those are the values you can have as inputs, nothing else. When you multiply, this is output actually multiplication. When you multiply 0 into 1, 0, 1 into 1, 1. Then you can see the output and the this output and the A. What happened? Equal. Output is 0, 1, A also 0, 1. Therefore, you can say Q is equal to which one? A. Q is same as A. Is that clear? This output is 0, 1 and C, A also 0, 1. Therefore, output should be equal to which one? A. Is that clear? Then the next question. Yeah. Given the truth table, now you should understand what is this gate actually. Huh? No. No. Yeah, you have to look at the. I explain how to get this kind of. When you get this kind of question, how to find the answer. First of all, you can write this one with inversion. Then this will be 0, 0, 0, 1. This output you get for what operation? You get this output for what operation? A and B what? Multiplication. A and B multiplication means what? AND. Then other column should be inversion of AND. Inversion of AND means not AND. Not AND means which one?
NAND.
NAND. Is that clear? It's not AND. Not AND means NAND operation. Okay? Is that clear? Okay, this question. What is output? This one also have the circle is there. And A is always 1.
Sir, B is the answer.
B is the answer. Here, let's see. Now, if you take the inputs A and B, then the output Q. Just create the truth table. So if you just take the truth table, now the A is only 1. A can be 1, B can be 1 or 0. That's all. So this one is actually output. When the inputs are 1 and 0, what happened? What's output? 1 and 0. 1 into 0 is 0, not 0 is 1. 1 and 1. 1 into 1, 1, not 0. That means it is inversion of what? Inversion of B. Is that clear? This output is what? This output is inversion of what? B. B is this one. Inversion of B means what is it? B bar. Is that clear? That's how you need to find the answer. Yeah, other parts we'll do next time. So you can try out. I'll discuss that part in the next time. So thank you for coming today. We'll continue the remaining. This is only the introduction part. And some questions we have to do some more sections actually with some past paper questions also. Thank you.